Hi everyone. In this session, we are going to study about electricity. Can you imagine a world without having electricity or power? Can you imagine a life without television, without light, without fan? No, we can't, right? In 7th standard, we studied about cell and battery, which we are using in calculators, watches, torches, and even in mobile. Okay. So in this session, we are going to study about the main electrical sources which we are using in our household purpose for running the fan, working the TV, refrigerator, for everything. Okay. A cell or a battery which gives us continuous current for a particular time. So we used to call it as DC or direct current. Okay, direct current is provided or DC is given by cell or battery. Okay, so the power supply which we are getting in our house, that is always alternating. Okay, it will be having ups and downs. 50 times the frequency of this current is 50 times. That means 50 times positive cycle and 50 times negative cycle. So this is called alternative current. Okay, alternative current or AC. This is what we are going to study today. So 50 positive and 50 negative cycle. This is negative. 50 positive and negative together. The frequency will be 50 Hertz. Okay, what is frequency? Number of oscillations per 1 second. Right? So one complete cycle, 50 positive cycle and 50 negative cycle. So the frequency of the alternating current is always 50 Hertz. We know that current is due to the flow of electrons or the movement of electrons. And we studied that there is a potential difference existing between cathode and anode, or we used to call it as positive pole or negative pole. Okay. And what is current? It is a rate of change of flow of current. Right now in a particular or in unit time, how many electrons are crossing a particular unit cross section, that constitute the current. Okay. So in this session, just consider that we have a resistor. Resistor in the sense of resistor, just consider this is a bulb. Okay. I'll draw it as bulb itself. This bulb always offer this bulb be connected to a cell. Okay. Through a key or a switch. So just consider that always how the current will travel from positive pole to negative pole. This is positive and this is negative. Just consider that current is passing through this circuit and it offers a resistance. This bulb, actually we have to show like this way. It always offers a resistance. Resistance means it is a blockage offered by the current flow by the circuit. Okay, so it is an obstruction offered by the circuit for the current flow is known as resistance. So just consider that, and it is represented by the letter R. Okay, so just consider that current is flowing through the circuit, that is I, and this bulb offered a resistance of R when it is connected to a potential difference of V. Okay. So we are going to find out energy. We know that energy and work done both are same. Okay. Just consider here one electron is there. So we are going to define the energy. Energy in this circuit. So that is our work done. So work done is equal to, or it is the amount of work done to bring a unit positive charge or unit charge from here, starting from positive point. Then it's going over here and it's coming back to the another pole. That is what we call potential difference. Okay, so we can define the potential difference in terms of work done. It is the amount of work done to bring a positive charge, a charge from one point to positive point to the entire circuit. That is called potential difference. So, in terms with this one, we can define work done. Work done is equal to, it's carrying on. We studied that potential difference is equal to work done to bring a charge. So, here work done is equal to charge into V. Okay. And we studied the equation for current. Current is equal to charge by time. Okay. So, I am going to substitute this Q. What is Q according to this equation? Q is equal to I into T. If I substitute this value here, we will get it as ITV, or work done is equal to, actually we used to write it as VIT. Work done is equal to voltage into current into time taken to carry out this electron. So this is our electrical energy. Electrical energy is providing a current for time T when it is under potential difference of V. Okay. So this is the electrical energy. We can write it as E, electrical energy. Now what is power? We studied that power is equal to work done by time. Okay. So what is work done? Work done is equal to VI by VIT again divided by T. So power is equal to voltage into current. Okay. So power is equal to voltage into current. The unit of energy we know that is joule. Right? No, unit of energy is always joule. Now let us find out what is the unit of power. Now what is the unit of potential difference? That is volt. On behalf of Alexander Volta, the potential difference unit is given as volta. Okay. Then what is the unit of current? That is ampere. It's also given on the honor of Alexandro Maria Ampere. So ampere, voltage or volt into ampere is a unit of power, or instead of that we can write it as watt. Volt ampere is known as watt. Or else we can write it as 1 watt is equal to 1 volt into 1 ampere. Okay. So 1 watt is equal to 1 volt into 1 ampere. So this is our electrical energy. Electrical energy is providing a current for time T when it is under potential difference of V. Okay. So this is the electrical energy. We can write it as E, electrical energy. Now what is power? We studied that power is equal to work done by time. Okay. So what is work done? Work done is equal to VI by VIT again divided by T. So power is equal to voltage into current. Okay. So power is equal to voltage into current. The unit of energy we know that is joule. Right? No, unit of energy is always joule. Now let us find out what is the unit of power. In this session, we are going to study how the transmission of power is happening from the power generating station till our home. Okay, so we know that the electricity is always generated in power stations. We have different kinds of power stations like hydroelectric power station, thermal power station, nuclear power station. So how it reaches our home, that is what we are going to study in this session. Okay. So we know that the power generating station will produce electricity, right? So that electricity is in terms of 11 kV. Every time for all the power stations, we are generating the power at a voltage of 11 kV. Okay. Just consider this is a power station and it generated with a voltage of 11 kV. Okay. In the power station itself, we will be having a substation. Okay. There will be a generating station, power substation. So we know that we have a power station very far away from us, right? No? Is it every village we have power station? No. So in one state itself, we will be having 4 or 5 power stations, and from that power station the entire state will get the power supply. So right now, so the electricity has to travel a long distance, nearly 200 to 400 kilometers to reach our home, right? Okay, so from the power station we are getting the electricity with a voltage of 11 kilovolt or 11,000 volt. That won't have the capacity to reach our home after this much of travel, because in between the energy will lost in the form of heat energy. So before transmission, it will be step up to 132 kilovolt at grid substation. That substation will be always associated with the power generating station. It will be stepped up to 132 kilovolt at grid substation. Okay. Now this is ready for the transmission, long distance transmission. Okay. Then it will be given to the main substation. Main substation. At main substation, this 132. Actually, what is the voltage we require in our home? That is only 220 volt. Okay, we need only 220 volt. Now, from the generating station, it is 11,000 volt. Now, we made it as 1,32,000. In main substation, we are reducing after a long distance we received in our nearby area. So it will be step down to, we are step downing to 33 kilovolt. Okay. So some industries require this voltage to function their factories. So that will be given to heavy industries. Okay. It will be given to heavy industries. Now it is only reached 33,000. We require only 220 volt. So again it has to reduce to 11 kV. So for main substation, again it will be stepped down to 11 kV at intermediate substation. Okay, it is happens at intermediate substation, and some industries require this 11 kV, light industries. So it will be given to light industries. Okay. Now it's only reached 11 kV. Again, we have a city substation that will reduce or step down that to our 220 volt. City substation will again divide that into 220 volt, and from the city substation it will be distributed to our home with 220 volt. Okay, so this is the way how power is transmitted from the generating station. This is our generating station. From generating station to individually to our household purpose. So from the city substation, the power supply or the current electrical energy is distributed to our home. So during this transmission time, always we have 3 lines. Okay, the current is taken out through 3 different cables, that is called live wire, or we used to call it as phase wire. Okay, phase or live is represented by the letter L. Then there will be a neutral wire, it's represented by N, and there should be an earth connection. Okay, it is E. Okay, before distributing to the houses from the city substation, this neutral wire and earth wire will connect to 0 potential or 0 volt. Okay, so we used to call it as earth one. So neutral connections potential is always a 0 volt, and this will be having 220 volt. We know that as in the case of cell, always the current travels from high potential to lower potential, right? Positive and negative is here. So here for maintaining that potential difference, 220 is a high potential and 0 is a lower potential. So the current is always, we know that till that potential difference is maintained, the electricity or the electron flow will be there. To maintain that, live wire will be having 220 volt and neutral and earth will be having 0 volt. Or we used to tell that this is the path. If these two, actually we used to represent the AC power supply with this symbol, okay, and DC with this symbol, okay. So if AC is connected to a bulb through a key or a switch, so this is the way how the current, this is a 220 volt live connection through which the current reaches the material or the equipment. Then there is a return part that is connected to the neutral wire. So live wire is a connection towards the material and neutral is a return path for the electricity, because we know that there should be a continuous path, then only the electrons or the current will flow through the circuit. Now let us see what is the color code for these different wires. We know that while we are constructing the house or buildings, we have to do the electric connection. Then only we will be able to connect different electrical appliances. So while doing that electric connections, we have to follow a color code system. Okay, for each equipment required is live wire, neutral wire and earth connection. So we are not supposed to use the wires according to our wish. So when we are going to purchase the electric wires, the colors, the different wires will be available, different colors. Color in the sense I am talking about the insulation, not the inside part. Insulation will be of different colors. But we are not supposed to use according to our wish, like purple, orange. So such kind of colors are not applicable or not advised to use for the wiring system. There is a prescribed format. Otherwise, if just consider that if one person or you are selecting the colors which you like most, okay, then after a few years you left the home and somebody else is now living in your home, and some equipments got fault and they want to repair that. So they call another person to repair. So if you use the color code according to your wish, the other person may not be able to identify which is live wire and neutral wire. Unknowingly, if that person will touch the live wire, surely he will get the shock. Okay. To avoid that, entire world is using a proper color code for the wiring system. Okay. So live wire, the color code is allowed to use is either red or brown. So whoever will come for service with the electrical appliances, they also will be checking the color code, either red or brown. That is always meant for the live connection. Okay. For neutral connection, it can be black or light blue. Okay. So this black or light blue is meant for this neutral connection, and earth connection is given by green or yellow. Okay, so these are the possible wires we can use it for connecting live, neutral and earth connection in our connection wires. Okay, now why we want to use this alternating current in our home or in the normal purpose? DC, there is no option for increasing or decreasing, but by using the step down or step up transformers, we can change the alternating current according to our purpose. Either if you want 11 kV for the industrial purpose, that can be used. For household purpose, we can use it as 220 volt. So different variations are possible from the alternating current. That's why for working all the appliances, we are using the alternating current instead of DC current. Thank you.